Students, welcome once again to my channel. Now this time we are given we have a vector question over here. Give the vector for the point and find its magnitude, and also determine if the vector is a unique vector. Now the position vector for so we're given the position vector for as 1 over 2, the coordinate as 1 over 2, and therefore negative root 3 over 2. Now one thing I should know is that for a vector, we have the coordinates of the ending point and the coordinates of the starting point, right? So to find the vector itself, it's just the coordinates of the ending point minus the coordinates of the starting point. That's the general idea to find the vector, right? To give the vector for the point. But then also since we are given the position vector as that, then this implies that the starting point for any vector is just the origin. So the starting point is just the origin, and also the ending point is where we are moving with, right? And what we are working with, or what we are moving with. So in this case, we can therefore conclude that if the position vector for this is given by this, then which means that so therefore the condition of the position vector is basically the condition of the point. So if we have the position vector this, then basically if we are to write the vector of that point, then we can write, let's say vector v here is just equal to just 1 over 2 here, and therefore negative root 3 over 2. So it's just the same as that. That will be for the first part. Now the second part says that find the magnitude, right? So we have to find the magnitude of this. The magnitude of this is just equal to the square root of what? 1 over 2 squared here, right? Then we have it plus the root 3 over 2 here squared, remember it's negative, right? So we have this as just 1 over 4 here, then plus this gets rid of that, negative goes away, we have 3 here being divided by 4, right? And therefore the magnitude of the vector, so let's use the magnitude here. We're looking for the magnitude, right? All right, so the magnitude of the vector here is just equal to so we have 4 over 4 here, which is just equal to 1 here, right? So that will be the magnitude of the vector. Now the second question says that the position vector for that, so we should find the last question says that determine if the vector is a unit vector, right? So if it is a unit vector, for a vector to be considered as a unit vector, which means that the magnitude of that particular vector must be equal to 1. So since in this case the magnitude of v here, vector v here, is equal to 1, therefore we can conclude that v here, so vector v here is a unit vector, right? So we can conclude that vector v here is a unit vector. All right, so thank you very much for joining me in this session, and I'll see you guys in the next session.